everyone. Welcome to the Basic Weather Spotters course presented by the Village of Glendale Heights Police Department, and the Glendale Heights Emergency Services and Disaster Agency, and the National Weather Service. We'd like to thank everyone for coming out this morning and for your interest in this subject. My name is John Takas. I'm a 6-year member of the ESDA unit. I'm the Deputy Field Coordinator in charge of training and street operations. I am also a full-time code enforcement officer for the Village of Glendale Heights, and I'm the point man for damage assessment teams that go out after storms or severe weather events. We have first responders here, we have second responders, we have some CSOs, we have people from the village, we also have people from businesses here in the community, and we also have citizens who just want to be prepared. I'd like to thank everyone who helped put this together, especially Marie Schmidt, who spent most of the last 2 weeks compiling lists and sending out emails. John Hansen, our field coordinator, who also helped put this together, and where's Jim Unger? Jim Unger, this was his idea. He was the one that initially contacted the National Weather Service and got this ball rolling. So we've all put in some time, and we're glad everyone's here. A couple housekeeping notes, exits where you came in. Bathrooms are located behind the check-in table where you were this morning. We have bottled water out there that's available. When the class is over, we have certificates to pass out, so when you leave, you can stop by the table, pick up your certificate, or there's also we printed up some links to the website where you can print it up at home if you choose to do so. Okay, our presenter this morning is Stephen Rodriguez Jr. He's currently a general forecaster and has been a meteorologist with the National Weather Service Forecast Office in Chicago and Romeoville since August of 2007. Before working for the Chicago office, Stephen was stationed in the National Weather Service Forecast Office in St. Louis, Missouri. His educational background consists of a Bachelor of Science degree in Meteorology from the University of Oklahoma and a Master of Science degree in Meteorology from St. Louis University. During his master's work at St. Louis University, Stephen conducted research on mesoscale convective systems, and Stephen enjoyed this research transferring over to his thesis work, as he had a strong passion and appreciation for the various modes of severe weather. So without further ado, Mr. Rodriguez.
Thank you very much. Can everybody hear me okay? Just, if you can't, just let me know. But once again, I'd like to thank you all for coming out to this water cocktail this morning, tracking through this cold. I know it seems a little bit awkward wanting to talk about severe weather and storms when we've got an inch that just fell, and we're expecting 4 to 6 more inches tonight and tomorrow morning. But nonetheless, now is always a good time to be prepared and ready for severe weather, because as we all know, there are certain times of year that we can't expect it to be a common occurrence, but then other times of the year, November or even a week and a half ago, that it can definitely surprise us and be on our doorstep at a moment's notice. So being prepared is always a good thing to do. The talk here this morning will probably last about an hour 45 minutes to 2 hours. Sometimes I'll leave it up to the audience. Sometimes I like to just push right through it. There's about a halfway point in this talk that we could break for about 5 or 10 minutes. During that time frame, I'll ask again and leave it up to you guys. So if you want to push through it, or if I'd like to get a 5 to 10 minute break. We will be talking about a wide range of information consisting of the basics of meteorology, how to find information from our Weather Service agency, as well as what do we look for certain storms and in certain locations to help be the best spotter you could be and to provide the good, solid information, not only to your community, but of course to us, the National Weather Service. So that being said, why do we need spotters? Well, the main thing, or the main aspect of looking at severe weather and how we actually issue warnings when we get to that point is actually with radar. But our radar has limitations. It's these limitations that really hinder exactly what we can see and what we cannot see across the entire area. So these spotter reports are used to verify not only what we are seeing, but maybe really kind of use that to help calibrate some various aspects of the weather that we are monitoring at that time. And these spotter reports are a vital part of the warning decision-making process. So the limitations that I just briefly mentioned with the radar can be really quickly looked upon by this image that we're seeing here on the screen. The radar in the left part of the screen sends out pulses of energy that goes out into the atmosphere. These are very rapid, high-energy pulses that will scan to one location and then continue to move around the entire environment, not only looking at one portion of the atmosphere, but then moving up an angle and continuing to scan the entire environment. What we're seeing here is that as it's being leaved, it's actually not leaving in a horizontal, or at least parallel to the ground. Not only do we have the Earth's curvature effects that we have to look out for, but the fact that this beam is actually going out in a half-degree angle. So the further it moves away from the radar, the higher up in the altitude we are seeing, or we are sending this energy. Storm closest to the radar, we can really get a good slice of the entire thunderstorm, but as you see here in the image, you move further away, there's really only portions of that thunderstorm that we can see, and where that question mark is where a possible tornado could be. So that is one aspect, or one limitation of the radar, is that we cannot see the entire scope of a thunderstorm at certain locations. And so, of course, that's where spotters come into play. But looking at the warning decision-making process, we actually look at it from a rule of 3 here, and that includes the Doppler radar data, spotter reports, as well as the environment. And something we've been trained on by the science, by our training officers, is that if we have 2 out of those 3, we can issue a severe thunderstorm warning or a tornado warning. If we are seeing indications on radar of possible circulation and it is in an environment supportive of tornadoes, we will more than likely probably issue a tornado warning, but have it say radar indicated. On the other hand, maybe we're seeing on radar, and we've got a report from the spotter of a tornado on the ground. There's our 2 of the 3, and we have that's a tornado warning out. One thing to always note too, that as reports come in, we have to continue to investigate. We have to continue to make sure that what we are hearing matches what we are seeing on radar and matches what could happen in the environment. So if we do field a report from a spotter saying that there is a tornado, we will more than likely try to correlate that to what we're seeing on radar. And if it doesn't really maybe jive, we'll continue to seek more resources to try to confirm if a tornado is occurring. And you'll see as we move on in the presentation as to why we would do that. But here's a warning that we got. This basic text talks about a severe thunderstorm capable of producing a tornado was located near Addison. So this is actually text from a tornado warning. And notice that the source there in the middle is that it is radar indicated. So we don't have a report at this time, but what we are seeing on radar could lead us to believe that there is a possible circulation that could lead to a tornado. So there at the bottom, you would see on the warning tag there, the tornado is radar indicated. So, how many people really react in this day and age to radar indicated? It's nothing confirmed, it's just what we're seeing on radar. But what if we now have a tornado warning that says a confirmed tornado was located near Addison? So not only is the tornado warning out, but it's confirmed, and the source was a law enforcement agency that confirms this tornado. So then on the tag at the bottom, it would be observed. I would think more people are going to react more to a tornado warning that says confirmed tornado as opposed to a tornado warning that says radar indicated. And once again, this just goes to the fact as to, not only our partners with the emergency managers, but the public, communities are all vital parts of this whole warning process. So continuing on to why spotters are important, why visual aspects, confirmation are important. We can look back at back in 2011, where there was a pretty good outbreak of tornadoes across the plains and Midwest here. And the first image here that I'm showing you is just an outlook from the Storm Prediction Center, trying to give you a heads up, days 1 to 3 of the potential for severe weather across the area. So we're actually going to look more in terms of the Joplin, Missouri area, because that was a location that did observe a rather violent tornado, EF5 tornado during that location. And the service assessment that was written up after the fact included interviews with various individuals. And one individual noted that, you know, he knew about the potential for tornadoes days in advance, but yet during the day of the event, he still went out about his business. He did notice that the clouds were starting to get a little more scary, and then at this point, clouds were scary. I actually heard the tornado siren. Sirens went off, letting him know that there was a tornado warning issued for his location. But he didn't actually take cover. What he did was he went out to a restaurant to go get dinner and then maybe try to confirm what was going on. So continuing on, he's at this restaurant, and the first one he gets to actually is closed because of this tornado warning. But he doesn't go home. He goes back to a second restaurant to get dinner, and they're actually open, so he does get dinner. Clouds are getting scarier, but still at this diner. And all of a sudden, there is confirmation from spotters in the field that there is a significant violent tornado on the ground. At that point, people in the restaurant know that, and they finally have confirmation that there is a tornado on the ground. And the restaurant closes and sends everybody down in the basement. The point being is, in this day and age, individuals need multiple confirmation. They actually need confirmation, but not only confirmation, they need multiple sources of confirmation. And just the actual confirmation from spotters in the field is just was a tremendous help to the tornado, severe thunderstorm warning process. So confirmation, getting that visual aspect of what's going on in the field. So we'll continue on talking about some of the products that you will see leading up to events and during events. The first product here, the image we are seeing is of a watch across northeast Illinois and much of northern Indiana. A watch means that conditions are favorable for the development of severe thunderstorms or tornadoes. This watch is actually not issued by our local office here, but rather issued by the Storm Prediction Center down in Norman, Oklahoma. We're not completely blind as to what's going on. We're in direct coordination with them 24 hours a day, 7 days a week. Even up the minutes before this watch is issued, I can still have input as to exactly what counties I want in this watch. But nonetheless, it is issued by Storm Prediction Center. They typically last for about 6 hours, and they do cover a large area and portions of many states. The warning in itself, severe thunderstorm or tornado, basically mean that the severe weather, the tornado, is imminent and highly likely. This is issued by the local office, so it would be, for this area, would be the Chicago office in Romeoville. And it is based on radar, usually to help give us that lead time, but it also could be, once again, issued based on spotter reports or the environment as well. These are more short-fused warnings that are 30 to 60 minutes, and they cover smaller areas or portions of counties. And we can see in that image there in the bottom left, this might be a little difficult to see, but it is a polygon area. We do create storm-based warnings to really kind of try to capture the areas that are observing that severe weather and the areas that will observe that area. So we're trying to cover, but in the meantime, minimize that space. So that's why we are seeing these storm-based warnings. And also, I kind of want to stress too that we have sometimes in there, but a lot of the times, most times we will give you heads up if we are expected to see widespread severe weather. But that may not always be the case, and so it's the kind of the widespread aspect of that maybe a watch does not get issued, but there could be severe weather that happens. And thus, we do say sometimes warnings are issued with no watch in effect. So if there is not a watch in effect, make sure and still be prepared as to what could happen with regards to the environment that day. So what is severe? The first aspect here is hail that we're looking at. Severe hail is 1 inch or greater. Or with regards to wind speeds, we're looking at 58 miles per hour or greater. So those two measurements, as well as severe wind damage from this wind. So we're not really able to measure the wind where there's significant tree damage, limb damage, things like that, will kind of go in with the measurement speeds there for the severe criteria. But once again, 1 inch or greater or 58 miles per hour or greater. And of course, a tornado. This is a separate warning, tornado warning, as opposed to severe thunderstorm warning, but a tornado warning is in fact, of course, severe. But what is not severe? What makes up a thunderstorm? Well, lightning. Lightning does not necessarily mean that it is actually a severe thunderstorm. Even though you may be seeing just continuous lightning, that is not an aspect that makes it severe, or we're talking about flooding that makes it severe. Although they do have their own hazards associated with them, you know, lightning is definitely a dangerous thing. The criteria that we look at for a severe thunderstorm warning or tornado warning does not include lightning nor actual flooding. The flooding aspect would come in with a separate warning, albeit flash flood warning or just a regular flood warning. As we continue to talk here about our warnings, we're going to look at our impact-based warnings that feature tornado tags now that we have included on these products that we issue. We can issue a severe thunderstorm warning, this top bullet, but we can include tags on it that say tornado is possible. So maybe we're not exactly seeing something confirmed at that moment that would lead us to believe that a tornado is imminent. What we are seeing is a thunderstorm that is in an environment that could produce tornadoes. So in that situation, we would likely include that tornado possible. And once again, a storm has potential to produce a tornado with no clear radar signature at that time. The next one that we previously talked about, the tornado radar indicated. This is issued, with the tornado warning that a clear radar signature is present, indicating that a tornado is likely. And then the last one, once again, there was confirmation. So a tornado was observed, and so we would issue a tornado warning with tornado confirmed by ground truth, whether that's from spotters or our emergency management, law enforcement agencies. Our impact-based warnings, continuing with these just tornado warnings only, within the last year or so, we've really tried to improve upon how we convey our message to the public, to our partners. So not only are we saying, tornado warning, radar indicator, we're really trying to give more solid, concrete information that can be very useful to all of our partners and the public. These now include enhanced tags for various situations on where we're looking at possible tornadic activity. The top part here, where there would be no tag included, and this is the most often used. Tornado warning, tornado damage possible, but we are looking more likely for a short-lived tornado. With the second bullet here, tornado damage threat, we would include a considerable tag with this tornado warning if there is credible threat of a tornado capable of considerable damage, long-lived. This is actually rarely used. In the next slide, I'll show you that. But once again, rarely used. But we do need confirmation before we can actually include this considerable tag with the tornado warning. And once again, we are expecting, if we were to be expecting a long-lived tornado capable of producing considerable damage. The last tag there that would be included with the tornado warning is a catastrophic tag. This is extremely rare. When I was going through this updated training the last year or two, I was advised that I would probably, at most, issue one tornado warning that would have a catastrophic tag in my entire career. And that's, the one point that I would do it with, even at that end, it would be, highly unlikely. But this is for instances that are, the confirmed tornado, once again, is on the ground, but severe threat to human life and capable of catastrophic damage. So we look at some of the larger tornadoes that are just producing widespread damage. It was confirmed, and it's confirmed doing catastrophic damage to life and property. So these are all tags that now go along with the tornado warning. I really wanted just to educate you on those, because more than likely, around our area, we are just going to see those tornado warnings that don't have those tags included on them. But if you see a tornado warning that has confirmation and has considerable on it, or you see a tornado warning that has confirmation and catastrophic, these are definitely situations to not take lightly. So an example of exactly how rare these new tags are that we are issuing, just within the last couple of years, we've only issued one tornado warning locally that's had that considerable or catastrophic. And it was a considerable tag there at the bottom, talking about weather spotters confirmed the tornado, life-threatening, considerable damage being caused, and considerable damage expected to be produced from that point forward. And this was actually from this past November with the November 17th outbreak, as we saw those tornadoes move through west central, and east central Illinois, produced widespread damage. So very, very rare, but once again, if you were to see these tags issued with these tornado warnings, it's definitely something to not take lightly. All right, we'll continue moving on from as to why spotters are important, and more to how to prepare yourself with events, you know, the days leading up to or even the day of. So what to expect? Well, our basic website here that we have is weather.gov/Chicago. That is the National Weather Service website locally for Chicago, Illinois. And here is the image of that website that you would find. It's actually weather.gov, not weather.com. Just want to stress that to you. But weather.gov/Chicago will lead you to our local page here, where you can find a map of actually current hazards going on at the time. In this image right here in the middle, we are noting that there is actually some hazards in terms of flooding going on across west central Illinois as well as northern and northeast Illinois. But if you were to see colors indicating, or if there were a watch, whether it be a severe thunderstorm or tornado watch, you would actually see that on the map, color-coded with the key there on the right. A great product that we've issued over the last couple of years, and we've really kind of refined over the last year, is our weather story. And highlighted there in the bottom left there in the red is where you would find that weather story. It's just a great image trying to capture what you can expect, whether it's actually for that day or the days coming, and including as much detail that we can provide in that image. So it's a great quick tool to look at. The next box to the right is where you can find radar data to look at what's going on across the area. Same radar data that we are looking at our office. This is actually an image of that radar data, being able to choose various aspects of this data to look at. The main one you would want to look at here is base or composite. Basically just the lowest angle that you would see from the entire area. It's a good indication to look at what's going on maybe near the surface for the entire area of northern Illinois, northwest Indiana. And the other one here, like I said, the radar looks at the entire scope of a thunderstorm, and this composite will give you what's the strongest part of the thunderstorm and then show that to you on a base level there. But nonetheless, looking at this base reflectivity, as we call it, which would default when you click the radar, is what you would want to look at. The time there at the bottom, we do update this radar. The radar does update generally every 5 to 6 minutes, or 10 minutes when we're not expecting any weather at the time. You can change the radars from the radar that is co-located with our office in Romeoville to Milwaukee to the north, Davenport to the west, Lincoln to the south, North Webster, and then just continue on from that location. So you can look at other radar data. Not only do we have our weather.gov/Chicago, we actually now created in the last couple of years a severe weather briefing page. This briefing page is a real great one-stop shop for all outlooks, watches, warnings, our forecasts, radar, satellite, and storm reports, as well as our hazardous weather outlook. How many of you are familiar with our hazardous weather outlook? Just out of curiosity. Good to know. This is a great planning tool. It's a text product, but nonetheless, we can provide a lot of good information in there for severe weather potential over today or the next 7 days. It is issued around 5 a.m. or 5 p.m. Or actually, why is this 5 a.m.? It'd be 4:30 a.m. or 4:30 p.m. I apologize for that. It does get issued twice a day yearly, but as we get into the convective season here over the next month, you will see updates, mandatory updates at 11 a.m. as well. So not only 4:30 a.m. and 4:30 p.m. will there be updated information, but 11 a.m. as well. And then if conditions change that warrant an update to that product, we will issue that as necessary as well. But the hazardous weather outlook is a great tool to get a good idea, or the first idea of what could happen for the day. So going to our website here, weather.gov/Chicago, if you look there at the bottom, that is where you'll find that severe weather briefing page. I think it's the second bullet there on the right, severe weather briefing page. And if you were to click that, it'll take you to this new page here, and this is that one-stop shop I was talking about, where you can find not only information for what's severe weather, but you can toggle between flooding and heavy rain over to winter to extreme heat. And each of those tabs will have the various products that you would need to look at for severe weather or flash flooding in your location. Not only are you going to find radar data, local storm reports there, at the bottom, in the middle of the screen, you'll see highlighted in red, that's where you can actually find the HWO as well, Hazardous Weather Outlook, or HWO. And upon clicking that, this is a text product of that Hazardous Weather Outlook. It might be difficult to read, so I'll just kind of read it for you, but we break it down, if there are thunderstorms expected, we break it down into what can be expected, when it can be expected, as well as why the severe weather is occurring. But the weather hazards we are expecting in this product indicate isolated thunderstorms, strongest may produce, wind gusts over 50 miles per hour, heavy downpours, cloudy ground lightning. So we're trying to give an indication of all severe hazards, or at least hazards that would be expected. Areas and timing, we are expected thunderstorms to starting this evening. However, a greater threat of thunderstorms appears to be after 2 a.m., especially south of Interstate 80. And there below that, we just talk about as to why the thunderstorms are occurring, strong instability, cold front moving across the area, things of that nature. So once again, HWO is a great first stop there to really get a good idea of what's going on with the weather that day, and once again for the next 7 days. NOAA weather radio. How many people have a NOAA weather radio? Awesome. If you don't have one, it's a great tool. I know this day and age with smartphones and iPads and things like that, NOAA weather radio is still a great, I don't want to say simple because I don't want to, either way, it's a great tool to have. The NOAA weather radio is basically transmission that you can receive 24 hours a day, 7 days a week from the National Weather Service office in Romeoville. It provides forecasts, hourly weather, severe thunderstorm warnings, tornado warnings. All of our warnings get broadcast on that NOAA weather radio. What makes it really nice is that you can actually define it to your location, and not only for your location, but actually what products you want to come across your radio or not. So if I'm looking at the radar back at the office and I'm thinking about issuing a tornado warning for, Glendale Heights area, as soon as I issue a tornado warning and hit that button, it goes over to my radio and then sends out that warning out to individuals in this location only. And that's through the use of SAME or FIPS, codes that you can actually put into this weather radio to receive this information. But it's almost instantaneously. So I'm talking about in the order of minutes from me issuing the warning that it actually gets to your radio. Nice also, it's going to be a very annoying radio, meaning it'll wake you up in the middle of the night if it needs to. So definitely a good tool to have from there. That loud alarm will alert you, and once again for your county, your location. We provide the service. Yeah.
Does the weather radio have a grid of antennas, or is there just like one big antenna? What would it take to receive it reliably with an outdoor antenna?
There is one antenna for various locations. We have 11 transmitters, per se, you want to call it, across the area. Rockford, Chicago, there's one on top of Willis Tower, Lockport, Plano, DeKalb, I'm trying to think, Hebron, Indiana.
Crystal Lake has one too.
I'm sorry?
Crystal Lake has
Crystal Lake, yeah. So every location is covered under these transmitters, and I would say it's highly reliable to receive information from the NOAA weather radio. So I was just going to say that we don't sell these. We're of course like a government agency, but we provide the service free. These are radios that can be picked up at any retail place, anything like Radio Shack, Walgreens, things of that nature. The wireless emergency alerts, definitely something new here. Basically within the last year, police being sent out widespread. But the joint effort between the FCC, Department of Homeland Security, as well as the National Weather Service, to provide wireless alerts to your cell phones. These are offered by all major cell phone providers, and it comes to your phone just like a text, but with unique sound. I'm actually kind of curious, has anybody received one of these unique? Yeah, they sound a lot different, don't they? Yeah. But that being said, another great tool to have to help to save lives here. It is definitely a unique sound, but once again, it's not going to be for severe thunderstorm warnings, but it's only going to be for tornado, flash flood, and amber. And I believe we are actually evaluating whether we will continue the flash flood. Those tend to be issued maybe a little bit more frequent as opposed to tornado. So we did get some feedback from individuals that maybe flash flood not be necessary, but either way, tornado, flash flood, and amber alert. And I don't know if you had heard stories, but with the November 17th, there was a church that I think that was having service. Everybody was aware of the potential for tornadic storms that day, but it wasn't until everybody thought they had their phones silent in church that everybody's phones were making noises within that church, and that's because a tornado warning had been issued for that location that the phones were located in. So it was at that point that everybody knew something was bad going on, and so they actually took shelter, and actually it did save their lives that day. And that's what it would look like when it would come through your cell phone. Basically stating an emergency alert, but it will let you know what the alert is. Just a quick map here of kind of how it works. We issued tornado warnings with their polygon that have GPS coordinates located on that, and those get plotted within the map of service across your location. And then these towers, cell phone towers, receive this information, and through various means, they can figure out your location if you're actually in the warning or not in the warning to actually provide you that alert. But what we're kind of trying to show here is that through this new service, you'll never not be warned. You might actually be warned multiple times just based on where we're seeing coverage of these towers, where on the image you can see that there's overlapping coverage of those orange circles from various towers. But you will always be covered by this new service. We actually are now really have a strong push over the last year and a half of a social media presence on Facebook, Twitter, and YouTube. This has really shown to be a great resource, not only for our office to get information out to the public, to our partners, but for our public and partners to then share that information and actually be a place for all individuals to share our information. It's just a great tool to really reach out to the community and let everybody know what they can expect. I love the fact that we have our website, weather.gov/Chicago, but in this day and age, what's the easiest thing to look at? Your phone. Most likely people have their social media platforms on their phone. So it's just as easy for us to put that information on our website as well as put it on social media. So through this service, we're providing latest and up-to-date information, routine, useful information that includes graphical displays, as well as that interaction that I was talking about. Over this winter, there'll be times that we're not receiving snow reports. So I'll just put out a quick post on Facebook like, hey, just kind of curious if anybody have any snow reports. And within minutes, I've got 50 to 100 people telling me what they're receiving. So not only does that help me out, but if you were to see that come through on your news feed, you can easily go and see what people are getting around that area. And people do that. They speak with one another on there and pass along information. So it's a great interaction tool. But I do want to caution that we are moving forward with this great service, but we want to reiterate or actually stress the fact that the frequency of these updates may vary at times, and that our followers should still rely on normal means of service to receive their information. Website, NOAA Weather Radio, through your various emergency management outlets, things of that nature. So a great tool to have, but once again, still may be service through our social media outlets may vary at times. But here's just the quick images of what you could see. Back on November 17th, we had posted an image of that particular dangerous situation, tornado watch that was issued for that day. that received a lot of attention, as well as our YouTube channel, where we can actually provide multimedia briefings, generally of 3 to 5 minutes of what people can expect. And then, of course, we do also tweet this information out as well.
Do you guys have an application, like for smartphones? You know?
At this time, we do not have a specific app. Our mobile websites, it's mobile.weather.gov, can actually act as an app. You can just make it to go to your home screen, and then it turns into an app. But we are actually in process right now of building a full service app. So no exact time on when that would come out, but we are working on that. So beyond trying to be prepared what could occur during that day, or that next couple of days, having a good idea climatologically of what could occur is also a good thing to have as well. Here are just some periods of when you might expect various modes of severe weather: tornadoes, hail, high wind, flash flood. Generally for tornadoes, you'll see more common frequency between April and June, and a time frame of 2 to 8 p.m. Hail from April to July, likewise, that late afternoon, early evening time frame, as well as high winds more towards May to August, and same time frame. But as you get more towards the summer months, we all know that could be, of course, over the overnight hours as well. And then with regards to flash flooding, generally those larger systems and really kind of weak environments that provide those flash flooding setups, and that occurs during July through September, and afternoon through overnight. But that being said, they can occur whenever they want to. The environment is the environment, and it will do whatever it wants to do. This can be noted with the graph here indicating times of the day that you would see severe weather, the reports that we had received. And of course, those are more towards that late afternoon, early evening time frame, but we still have reports there, the overnight hours, 1, 2 in the morning. So nonetheless, it's still possible to receive severe weather at any times of the day. Looking back at February 29th of 2012, there was a 5 a.m. report, or January 7th in 2008. So severe weather can happen at all times of the day, at all times of the year. So just wanted to keep that in mind as well. The good safety aspect, a good acronym to live by, we stress, is called ACES, ACES, awareness, making sure that you are monitoring the weather. Communication, whether it's through a local Skywarn, amateur radio, or the EMA. Escape routes, be familiar with local road networks across your location on where you're at that time, as well as safe zones or shelters, being able to prepare and get indoors that quickly if need be. And these are all ideas for spotters that we stress, local emergency managers, things of that nature, so ACES. We do not encourage storm chasing, and we actually will not ask the spotter to drive into a dangerous situation, so that will never occur from the National Weather Service. As well as mobile spotting with a partner is always a good idea to do. Not only it's always nice to have somebody there with you, but one pair of eyes on the road as well as one pair of eyes on the weather, making sure that both parties or both individuals are staying safe. That is something nobody's going to do, right?
He's screwed now. He says so well now.
baffles me what people will do sometimes. I mean, those images in itself should be why you shouldn't, mess with hazards, and why, the previous slide we were trying to tell you to be aware of what's happening, what could occur, escape routes, knowing your environment, have people with you, because these hazards are very serious hazards and are not anything to mess with, especially flash flood like we saw there in that video. Quick definition for a flash flood is a rapid short-term flood, usually carried on by heavy rain. This is the #2 weather killer in the entire U.S. Nearly half of the flood fatalities are vehicle-related. And as you can see, these 2 points I've got right here are the fact of what rushing water can do. But we clearly saw what rushing water can do on those images. Just 2 feet can carry away most vehicles, including our big SUVs that we think are really powerful, or pickups that we think are powerful vehicles. But even 1 foot of fast-moving water can knock you off your feet. So, as we always say, turn around, don't drown. Kind of cheesy, but it makes sense. Yeah, why risk something if you have to? What you may think might only be a couple inches of water could quickly turn into a couple feet of water. So, turn around, don't drown. So although lightning is not, to be considered severe, it is dangerous. As we can see with this image right here, that an individual that was struck by lightning can do severe damage to our bodies. Lightning tends to strike the tallest object, so avoid standing next to trees, power poles, and other tall objects. If you are in an open area, you are the tallest object, so make sure you're aware of that. So definitely don't want to be the tallest object. You are safe in an enclosed metal-topped vehicle. If you are out in the field and you feel your hair stand on end, run to a nearest shelter. It's that static charge where you're starting to feel build. It works from the base of the thunderstorm down to the ground, and so those work hand in hand. If you start to feel that, you might want to take shelter. But I would hope also too that if lightning is in the general area, you wouldn't want to at least be outside during that time frame. But there is no safe place outdoors in a thunderstorm, like I said. Definitely something to be careful of.
Face that way, face that way. Face. Continue facing them.
Severe hail or large hail was that right here, that straight line advance downward. I guess as I'm showing you these videos, I should also stress that these are things that we don't want you to do. These are great for me to show you the hazards, but definitely not good things to do. I mean, there at the end, you can see the guy was going for shelter, which he should have been doing to begin with. But either way, hail and wind, also definitely not anything to mess with. Go inside a sturdy building for hail and high wind safety. Stay away from windows. They can shatter and become hazardous material themselves. For a tornado, the basement or small interior room at the lowest floor will offer you best protection. If you are spotting in a vehicle, make sure to keep a firm grip on the steering wheel. Wind speed and direction can change rapidly in and near thunderstorms. Heavy wind, blowing rain, or dust can reduce visibility. So that can actually pose a hazard in itself as well. And be alert to possible blowing or falling objects such as tree limbs, power lines, lawn furniture, trash cans, etc. In that image we just saw, those trees were quickly turned into projectiles, things that could pose serious hazards to individuals. Continuing on with tornado safety, only spot where you have a good view of the sky. Be aware of your surroundings and have an escape route. Do not try to outrun a tornado in your vehicle or in an urban area. Tornadoes can move at 60 miles per hour or higher. The tornadoes during the November 17th case event were moving as such, so these are very fast-moving storms. Definitely don't want to try to outrun them. As a last resort, lie flat in a ditch or a low spot. Continuing to reiterate the fact that a bridge does not offer protection from a tornado. The underpasses, bridges, they do not offer protection from a tornado. Be aware of falling debris out of the sky, even some distance from a tornado. And another hazard to keep in mind too, that tornadoes, especially in our general location here in northern Illinois, northwest Indiana, aren't always going to be visible. You aren't always going to see it. And it's these rain-wrapped tornadoes, as we call them, that are especially dangerous because what looks like rain could actually have a tornado inside of it. So something to keep in mind, these rain-wrapped tornadoes that we hear about.
One bar, here we go. Calling Omaha right now. There it is. Is that rain wrapped?
It could be a rain-wrapped wedge.
We believe it's rain wrapped at this point.
And these are
We are 4 miles west of Moorhead, and we do have a lot of circulation. We can actually see the rain bands circling around. We have the lowering that comes all the way to the ground, which leads us to believe there is a tornado, possibly rain wrapped at this point. We cannot see through the core because it's a very high precip tornado if it is on the ground. Okay. Yeah, I can hear you.
How about the stuff that's falling down?
Oh my God, the lightning was.
There's got to be a rain-wrapped tornado in there. You got to get on the air.
Yeah, that'd be great.
There's got to be a tornado in there, man. Look at the branches falling. Look at it, it's raining debris on us. Yeah.
People should not be driving.
Oh, dude, look at this. Oh, big branches. Holy sh.
We're right underneath it, dude. It's swirling right above us.
Oh, God.
I think we're in the tornado.
We are gonna go just a little further south. They're on. They were on. Look at the debris. Oh, dude. Ben, tell me, do you have an update? I got 42. Where is the rotation? We're in the rotation.
I'm going to take this.
Ben?
Oh, here
No,
it is
we're
right
in
here.
the tornado.
We're in the
We're in the
right now.
tornado. Our ears are popping.
My ears are popping.
Our ears are popping. The tornado is right over us right now.
Holy smokes. We are getting hit by a tornado right now.
We are in the tornado. We are in the tornado. Just went over us.
The tornado
Just went over us. In the tornado. We are in the tornado. We're in the core of the tornado. We're in the core of the tornado.
Right now, our car is about to tip over.
It's going by us. It's going by us.
I don't know if you can hear me with these high winds.
It's going
We have
by us.
100-mile-hour winds driving our car right now. There's tree limbs down everywhere.
It's going by us. It's going by us. Oh my God, we just went through a
I
tornado.
cannot believe that.
We just went through a tornado.
And these are people seeking out tornadoes. This was actually from some seasoned chasers that are out in the field. But rain-wrapped tornadoes offer more hazards. The fact that you can't see what's going on. They didn't even know they were in a tornado until the tornado was on top of them. So just another hazard to keep in mind.
Oh, look out, dude.
Tornadoes could be rain grass.
Oh, look at that sound like this. This network is coming. Look out, man. We got debris.
Listen to the roar. Listen to the roar.
Oh,
Roar. That's not good. I hope you're all right. Oh my God. Back up. Reverse.
no, we're good, man. We're good. It's not, it's gonna go right in that.
No.
Power flash. Both ways. Good.
Power line's down. Okay. It's search and rescue time now, bro.
Yeah.
What we kind of wanted to point out with that video is the debris. You know, they're not really anywhere near the tornado itself, but that debris is being flown about in a lot of different locations everywhere, and even as far as they are away from that tornado. So something to keep in mind too, that although you may think you're at a safe distance, be prepared that that you might not be, just due to flying debris from these tornadoes. I did mention that make sure you have a good spotting location that you can see all aspects of the tornado there, or of the thunderstorm, because right now we are seeing some type of lowering from this thunderstorm, but what we can't see from this vantage point is what's going on at the surface. So make sure you have a good view of what's occurring there at the surface, as well as, of course, the thunderstorm, because there could be a tornado on the ground or there could not. We just don't know from this vantage point. Night spotting, very difficult. I know it has to be done by various communities, but even harder than daytime spotting. The lack of light, of course, makes cloud features, rotation, very difficult to distinguish on thunderstorms. Lightning can sometimes illuminate these features, but only briefly will it do so, making it once again very difficult to clearly identify these features. As we noticed with that previous video, those power flashes could be an indication of damaging winds or tornadoes, things of that nature, but not always so. Night spotting, very difficult as well. As we saw there, I mean, you can kind of make out some features with some lightning flashes in there, but not really. So concrete, definitive, observations are very difficult at night. Just something to point out there to you as well as another hazard. But then, lack of information from that makes it difficult to even convey to various entities as well. So from this point on, we'll move on to some basic meteorology, some basics, and then we'll get back, after knowing that, to how to identify these features and what we would be wanting you to look for while spotting if you do become a trained spotter. But thunderstorm basics here. What is needed for thunderstorms to develop? Just general thunderstorms. We need moisture, instability, and lift. The moisture needed to fuel these thunderstorms comes from the Gulf of Mexico, even all the way up here across northern Illinois. It can also be provided from corn across the general region here. It can actually add added moisture to help fuel these thunderstorms. Instability, we're looking at warm, humid air, lighter warm, humid air below cold air, or this heavier air aloft. The biggest difference there, the greater instability, the larger the updrafts, and the more, or at least the stronger the thunderstorms can be, and hence more severe. CAPE is convective available potential energy. You might see us talk about CAPE in our hazardous weather outlook. Basically what we're doing is trying to measure the amount of instability that the thunderstorms have to work with. And then lift, anything could be a force of upward motion, fronts moving across the area, thunderstorm outflow, the jet streams aloft, things like that. So these are the three ingredients that are needed, that moisture, instability, and lift for thunderstorms. What also is needed for more organized, long-lived thunderstorms is what's called wind shear. This is basically winds that change with speed or direction as you go from the ground up. It's weak wind shear leads to short-lived thunderstorms, poorly organized thunderstorms. A lot of the thunderstorms that you see more towards the mid to late summer that go up and come down. Strong wind shear will lead to longer-lived and better organized thunderstorms. The thunderstorm life cycle, we can kind of see here from the cumulus stage to the dissipating stage, and we're just highlighting just a base kind of pulse type thunderstorm life cycle here. On the far left side, you've got warm air that rises, and then you go continue to rise, producing our cumulus that we see there in the summertime. It will continue rising, becoming clouds, rain droplets, and then it gets to a point where the rain droplets can overcome the buoyancy, and then that's how it falls back to the surface there. And then as it comes to the surface, it's encountering drier air, and it's evaporating as well. And it's this evaporating that helps bring this cool air down to the surface with the rain, and then it spills down to the surface in all directions in our mature stage, until it gets to a point where this cold air, the downdraft air, spreads out in all directions, and will then cut out our updraft of warm air, and that's when we have the dissipating stage, the dying stage of thunderstorms. So cumulus, warm air rising to a point where it rains, continued rain, and then it cuts off the updraft of that warm air, and then the thunderstorm dies at that point. Updrafts and downdrafts. So the updrafts are that warm air that is rising. There are areas where warm, moist air will rise into a thunderstorm. They're identified by dark, rain-free cloud bases. So updrafts, rain-free cloud bases, and these are under the cloud towers. So you'll see that kind of the dark area, smooth location, it's rain-free, you're not seeing any rainfall underneath it, and then from that point on, you're seeing the cumulus rising into the environment. These are also locations where you would see a wall cloud if a storm has one. You would see it in the updraft, or this rain-free cloud base. The downdraft, or where the rain, the colder air is coming down from the thunderstorm, often identified by heavy rain falling from this location. This heavy rain or hail will give it kind of a dark, milky appearance, more in the distance. So that's kind of marking the downdraft. But once again, updraft, rain-free cloud base. Your rain-free base can be identified as dark, flat cloud base under that updraft once again, with little or no visible precipitation and tall cumulus towers above it. There in the bottom left screen might be a little difficult to see, but we are noting that you see that little kind of dark, flat location. There is no rain visible in that location, and from that point upward, we're seeing the motion of cumulus clouds moving up from that point. That's our rain-free base, or our updraft. In the middle screen here, we have what's called a wall cloud. This is an isolated lowering attached to the rain-free base. Attached, I want to stress it there too, that, and others you'll see why in later slides, this wall cloud needs to be attached to the thunderstorm. What this is showing is, or at least indicating, that there is inflow and updraft into the thunderstorm, so it is growing. We are seeing the thunderstorm grow, and this wall cloud, once again, a lowering, but still attached to the rain-free base. And there on the bottom right is a shelf cloud. This is a low horizontal cloud attached to a thunderstorm, often wedge-shaped and elongated, and occurs with the downdraft. This is actually a feature that's more in line with squall lines, long areas of thunderstorms that we'll see move through areas, and we'll look in more detail in the coming slides. But the one thing, the difference between that wall cloud or even the rain-free base as opposed to the shelf cloud is the shelf cloud will span the entire horizon. It'll go as far as the eye can see, as opposed to this wall cloud or the rain-free base would be more confined in one general location, not the entire horizon. So here's another image here we've got of our warm air moving up through the updraft. Notice that dark, flat location there, and we are seeing No rain generally underneath that area of interest. We see our wall cloud there. It might be a little difficult to see in this image, but is a distinct lowering from the main cloud base, but it is attached. And then there, right in the distance, we are seeing our downdraft and heavy rain and hail. It has more of that murky appearance there in the background. Here is our, just kind of what we talked about. We're seeing the rain-free base there in the foreground there, solid area. And from that point, you're seeing the cumulus rise. That is our updraft that we're seeing right over there. Thunderstorm is fairly strong, but we are also noting within this updraft is that the real cumuliform solid texture of this is a real indication that it is a good developing thunderstorm with strong updrafts. We can actually play that again here. Good updrafts, cumuliform, strong texture to that updraft. Thunderstorms will continue up, and we're also seeing too above what we call the amble for the clouds there on the more towards the top of the thunderstorm that are spreading out in all directions. Is what we'll also see an overshooting top. It's reaching the upper portions of the atmosphere and getting to a point where it can't move any further, and that's kind of why we're seeing the amble. I'll go through that one more time. So the updraft reaches a point in the atmosphere that it can't go any further, and it spreads out. That's what we're seeing in the amble here on the left and right sides of the screen. But what gives an indication that it's a really strong thunderstorm is that we're still seeing that cumuliform, that motion upward above the amble on the side. It's so strong that it's actually moving into a portion of the atmosphere that it normally does not do. So that's a good indication that if we're seeing this cumuliform higher than this amble, that it's a pretty good strong thunderstorm. Here are some updrafts. We kind of talked about the rain-free base. There on the left screen, we're seeing more of a developing cumulus cloud thunderstorm, still rain-free base. You get more towards the right, rain-free base, but it's more a stronger thunderstorm, more, or at least growing more as opposed to the early on portion of the screen. So building cumulus on the left side from that base of the thunderstorm, and then more kind of a cycle thunderstorm on the right side, still rain-free base. That's kind of what we're talking about, where you can clearly see that there's no rain falling from the thunderstorm. That is where the warm air is rising. That's what we're seeing out of our updraft. And the reason we're really kind of stressing this is because these are the locations are where you would see the wall cloud, where you would see a funnel cloud or a tornado. And as we continue on, that's why I kind of keep stressing updraft, rain-free base, and that's where the wall cloud would be. Here's an up-close vantage point here up in the updraft. It's rain-free. You are seeing a wall cloud, a distinct lowering from the main cloud base. What we're actually also seeing in this image, and I will elaborate more as well, is what we call SCUD. It's stratocumulus under deck. What we're seeing is really good vertical motion, rising motion, and the environment in that general location is really highly saturated. So the clouds are developing pretty low to the ground as they move upward into that base. Something to keep an eye on to give you indication that there is upward motion, there is rising motion, and the storm is developing. But as we'll see also later, that this actually becomes a source of error when identifying such features as tornadoes, funnel clouds, things of that nature. But the main point I wanted to show is that if you start to see these little scraggly looking things, that it's good vertical motion into the thunderstorm. So at this point, we would continue on talking about actual individual types of thunderstorms. We can break here for 5 or 10 minutes if you guys would like. We're about halfway point for the presentation, or we can just continue pushing through. I'll definitely leave it up to you guys. Go and break. Talked about some good stuff, some good basic meteorology here, and I'm ready to get some really good questions. And hopefully, some of these questions, or at least I can provide answers to these questions I've received thus far with these slides as we move forward. But if you think of any questions you had prior, this point, or even from this point forward, I have no hesitation to fielding questions during the presentation, but if not, we can do like a Q&A afterwards and anything, whether if you actually want to ask while you have the opportunity. But we'll go ahead and continue moving on, and we'll actually get more into the thunderstorm types and the brief intro for kind of who I was. They talked about various modes of severe weather, or various modes of thunderstorms, and that's kind of what we're talking about. We're talking about more single, discrete thunderstorms, or we're talking about, you know, a multi-cell cluster, and a lot of thunderstorms kind of lined together, or we're talking about squall lines, things like that. We'll get into that right now with our thunderstorm types. We start off with our single cell thunderstorm. So that graphic that I showed you of the warm air rising coming down, that's a single cell, a thunderstorm, or pulse type thunderstorm. That's generally the thunderstorm that you'll see most often, usually not as severe. So we've got on this spectrum of minimal to significant threat there. It's more on the minimal severe threat side. Although there aren't a lot of great severe threats with it, it still can produce very heavy rainfall. It still can produce, you know, some decent sized hail with it, as well as when that core comes coming down, it can actually still produce some wind. So I don't want to say there's really no threat with single cells or discrete cells, but there's more minimal and more confined to that location. As you move on to the spectrum, we've got our multi-cell cluster over line, the squall line thunderstorms we hear about. Those get more and greater severe threat. Although as you transition to that kind of regime, although hail can be a significant threat, a lot of times with those squall lines, generally just straight line winds, those wind damage that you're going to observe it back. And then as we get into the far spectrum there, the supercell thunderstorm, you know, the name itself has really just kind of a powerful name, you know, supercell. These are the thunderstorms that pose significant severe threats, not only to hail and wind and even heavy rain, but also to, these are the thunderstorms that will likely, at least most tornadoes are associated with. Although not quite as a high of occurrence in our general area, we still do get those up here. Case in point, November 17th, all those thunderstorms that day were supercells moving across all of Illinois and Indiana. So once again, the single cell or the pulse type thunderstorm, most common during the summer. To occur with a weak wind shear, typically lasts 30 to 60 minutes, and it is, once again, has a minimal severe threat, brief localized wind, damage, or hail. Our multi-cell usually occur with moderate wind shear, can last hours to more than a day. It sounds kind of funny saying that, but it's these that can span, you know, regions, states, and then continue moving on throughout the overnight hours and into the next day. This includes squall lines. The most common threats, like I said, were damaging winds, marginally severe hail, and heavy rainfall. The squall lines of this multi-cell thunderstorm, once again, the most common. And as I had mentioned, spanning states. You can see with that top right graphic there that might be difficult to see the states here, but on the far left side there, that's Kansas, and you've got Missouri, Illinois, Indiana, and there in western Ohio. So spanning a good range of many areas across the Midwest there. Many squall lines have shelf clouds along the leading edge, and with this type of thunderstorm, worst is first. So with the squall lines, you're going to see the real strong winds push through, and then you're going to have heavy rain. I talked about a shelf cloud before, and then now I'm mentioning it again, and we'll continue to go in depth with these shelf clouds. But these are going to be a feature that sometimes get confused with maybe lowering, so those wall clouds, or the real turbulent motion to them, really kind of get people confused with exactly what they're seeing. But with this image right here, and I'll stress it now and I'll stress it again, is a shelf cloud will span the horizon. So, you know, maybe there was a shelf cloud moving right now across the area. We would see the shelf cloud from there all the way over there. That's the difference between a shelf cloud or a wall cloud, at least, you know, in terms of coverage there. But once again, with the squall line, you're going to see the downdraft come through, the strong winds, and then at that point, that's when you're going to see the rain. Here is kind of a schematic of a squall line, and note that the motion is from the left side of the screen to the right. The updraft goes into the thunderstorm, it feeds it, sending warm, moist air into that thunderstorm, where it then comes back down, hits the ground, and spreads down in all directions. But since it's most movement, it's usually aligned with the front. That wind is more than likely going to go spreading out with its momentum. And in this picture, it's movement to the right. So we've got, with the somatic, the updraft, the cumulus cloud, really kind of defined, really good solid textures of the cumulus. Here is our anvil that we talked about, and then the cumulus exceeds that anvil, and that is our overshooting top. Once again, an indication that it is a strong thunderstorm. It is rising into the portion of the atmosphere that is not normally conducive for upward motion. But the anvil in itself right here is showing generally where the thunderstorm should be limited. But updraft and then downdraft and the movement there to the right. Here is an image kind of trying to show you what it would look like if we were looking at the same schematic. Here is the shelf cloud, that is the visual clue, that it is a swell line. Once again, spanning the entire region here. You can see all the way to the horizon, up to the foreground here in this image. A derecho, I don't know if you've kind of heard that used. A lot of times, one media outlet gets a hold of it, every media outlet gets a hold of it. But nonetheless, it is a meteorological term, and it actually has a definition that it is a widespread and long-lived windstorm associated with a band of rapidly moving thunderstorms. You can see in this image, you see the swell line developing across northwest Indiana and continuing to expand and cover in intensity as it moves eastward into Ohio and then there into the east coast. And what makes us different from just a normal squall line is actually probably its definition in itself is that it's a swath of severe winds that extend more than 240 miles. And so maybe you have a squall line that it produces severe weather, but then it dies, and then maybe it redevelops again. The derecho itself will just have continuous wind damage from one location into the other. Just kind of something to give you an idea that if you hear derecho, it is a squall line that is highly severe and producing wind damage. What's also interesting with the derecho is the intensity that this damage can be. On the bottom right here, we've got note that a derecho can produce destruction similar to that of a tornado, but the damage is typically directed in one direction along a relatively straight path. And that's where the straight line wind comes sometimes used. It is these high intensity, these strong thunderstorms that produce wind damage that, everybody says it had to have been a tornado because, thunderstorms don't produce this type of wind damage. But these systems can produce winds at upwards of 100 and 110 miles per hour, and those are just as strong as the weak, tornadoes. So definitely are thunderstorms that can produce a good amount of damage. Continuing on with the shelf cloud here, the top left screen here, shelf cloud, we're seeing here is more laminar, smooth looking from the outside looking in. It spans the entire region here. I'm only giving you just a view of it from this point. This is up in Freeport, Illinois. From one side of the horizon, it would extend all the way to the right. Looking at it from the front, smooth texture to it. Here at the bottom is a better aspect of this shelf cloud. One side of the horizon, to the other. Smooth, a little laminar looking look to it. But what's interesting to note is as this moves across the air, you're going to see, that wind shift. You're going to feel that cold wind push out, and as you get underneath it, you kind of call this the whale's mouth. It really looks real turbulent looking, real ragged, a lot of different motions going on underneath that. And that's where people get a lot of confused as to exactly what they're seeing. Here is the shelf cloud pushing through an area, and we'll continue to see the features that we talked about progress as it moves forward. There is our shelf cloud defining there. And as you start to get underneath it, look how turbulent this really is. You're starting to see a lot of different motions. We're seeing that gust front, that cold wind push out from it. Next, we play that again for you if you like. But as you start to get underneath it, it really gets turbulent looking. And the images that will follow really kind of gets people confused of are they actually seeing rotation within this thunderstorm. See how turbulent that looks as you get underneath it. You can see the dust coming from this thunderstorm, and the winds that are spreading out from this line of thunderstorm. And here is kind of what I was talking about. Very turbulent looking, really scraggly looking thunderstorms. And even on the right here, you can almost make it looks like some type of circulation. You can see it kind of spreading inward, and swirling around. A lot of people will report us that they're seeing circulation with this thunderstorm. When in reality, it's just very turbulent underneath it. So there's just motions moving all over the place. And it just so happens in that location that it's kind of spinning in one location. We're now not seeing rotation with the thunderstorm. You're just seeing that dark, turbulent, and really windy look to the clouds. It has a concave appearance. And once again, spotters may see some swirling, but tornadoes are not likely under this location. This is not a location when you have that shelf cloud that spans the entire area where you would see tornadic development. You will not see that underneath this shelf cloud. So if you were to see some type of movement like that, more than likely it's just really erratic. You could just continue to look at it, and you'll likely see that it won't look like that seconds later. So just something to keep in mind. A highly unlikely place for tornadoes, as it's a cool location of the thunderstorm. Roll clouds, these are similar to shelf clouds, but they're more tubular, excuse me. What's different from these is that they are detached from the storm base, and they take on more of a slow horizontal rolling motion. So kind of the biggest feature here is that they're real more detached from the base of the cloud. Still an ominous looking feature. It's similar to the shelf cloud, but once again, not a location that you would see tornadic development within the roll cloud. You can kind of see that they're really not detached to any thunderstorm. You're just seeing, as the system moves across, clouds is developing. I'm going to do that again. And it is kind of rolling per se, if you want to call it that. We're seeing that roll cloud, but once again, not attached to the thunderstorm base. Continuing on, we'll move on to supercells. These are, I would say, are one of the more fascinating thunderstorms. Not because they're the most severe, it's just that they're unique. They can modify environments themselves. And just looking at them from an appearance, I always like to say they look like the mothership. You know, it's those thunderstorms by themselves that are just, you can tell something's not right there. But they are the rarest type and potentially the most dangerous. They have a rotating updraft, or as we call a mesocyclone. That's just the rotation that we're seeing that actually is apparent with wind shear and then gets tilted as an updraft is formed. So there's a rotating updraft with this supercell. They're the most common in the spring and early summer. These are thunderstorms, like I said, that they can modify the environment, so they can last for many hours. Threats include tornadoes, large hail, and damaging winds. And the responsible for the most large hail, and it's actually that rotating updraft is what helps it provide some of the largest hail, because the hail gets lofted and continues to stay in the thunderstorm due to this motion within the thunderstorm, and then continues to build ice accretion through the water and the ice in the cloud, and then at one point it becomes so heavy that it then falls. But because the thunderstorm updraft is so strong with this, it takes large hail for it to then fall out of the storm, and that's why this is responsible for the more large hail and significant tornadoes, because of this rotating updraft. The supercell is often discrete by itself, may have a distinctive radar signature out. We've heard of us, or individuals talk about the hook echo often present. You kind of make out that there is a hook to this thunderstorm, and that's a lot of what you'll hear. A lot of times too, we say, not on here, but it kind of looks like a screaming eagle, and it kind of spreads out. What we're noting with this is with the hook echo, or just the environment itself, is that the mesocyclone, the rotating updraft, is actually providing this distinct image on the radar imaging by lofting rain, hail, and spinning it around and then forward into the storm itself. So what we're actually seeing right here is actually some type of motion, or at least the rain or hail that's being created by this rotating updraft. And the mesocyclone, or then the possible circulation that then leads from that mesocyclone, would be located in that hook, right in this general location, or usually the point where the hook comes back around. So that's where the possible tornado, if the storm were to develop, a tornado would be located. Here's another schematic with the radar there on the left, and it's just kind of a conceptual model or idea that we have for this supercell, noting the hook appearance And what I talked about, kind of the screaming eagle, almost looks like wings. We can kind of talk about here from the left to the right. The hook is from the rotation of this updraft. And what gives it kind of this screaming eagle effect is that this red, the higher colors, the warmer colors, you're seeing a lot more hail, a lot more rain. As you get towards the weaker colors, greens, yellows, it's less rain, less hail. And noting that in this general location, it's not as intense as it is in right here, or as it is over on the right. And that is because there is a strong updraft that's not letting the hail or the rain move forward through it, because it is so strong and because it is rotating. So just something to see, features to see if we're seeing this distinct thunderstorm, does it have that hook echo to it, or does it have kind of a wing screaming eagle look to it? Kind of two things to note. Under the schematic here, what you will then have is what we call the rear flank downdraft or a forward flank downdraft. The forward flank downdraft comes from the rain and hail being wafted up to the forward portion of the storm, where there falls and it kind of spreads out with our cold air, the gust front. And there on the back is the air moving around from the rotation of the thunderstorm and then reaching the surface and then pushing out. And it's when this air kind of comes back around and goes down to the surfaces is when we likely start to see tornado genesis or that tornado develop. And as we'll move forward too, we can actually kind of start to see maybe indications of this occurring with a clear slot, and I'll show you more images of that as well. But here's a supercell structure, same storm from the last slide, but just more of the panoramic view. If we were looking at this storm, we would see, once again, our rain-free base. This is that rain-free base of that solid, kind of dark-looking area of cloud. You see the cumulus cloud, the updraft. This is where the wall cloud would be. But it does produce a tornado. That's where the tornado would be within this updraft, within this main thunderstorm. This is the main thunderstorm tower, and these are the moisture, the towers feeding into this main storm. As we call it, the flanking line, where you can see that the moisture is being pulled into this thunderstorm. Once again, the rain-free base, wall cloud. The overshooting top, here is our anvil. This is the location in the atmosphere where generally thunderstorms should not be able to rise above, but because the thunderstorm is so strong, it is rising beyond that from the atmosphere. That's where we're getting this overshooting top. And then the downdraft with the rain, the cool air, and the hail then pulling down in all locations from that point. Also, too, I don't know how many people are familiar with the Mattis clouds. It almost looks like fire is moving in the sky, really turbulent looking. That's when you would generally see this over here. Just indications that the environment is really turbulent, a lot of different motions going on in the environment. But these are very, very distinct looking clouds that are interesting, but really kind of pose no real severe aspects to it. You are noticing the rain-free base, dark, there's no rain. You see over here to the right, this is where our downdraft, the rain and hail is, there's a little murky color look to it, clear, murky look to it. Rain-free base, updraft, wall cloud, and this is where a tornado would form if it were to form. I mentioned that clearing in previous slides, and that's kind of what you'll see here too. No rain, but you're seeing clear, almost like clear skies, it's looking really lighter. That's an indication that some of this dry air is being wrapped around, and you're not seeing any of the rain, you're not seeing any of the clouds. That's a good indication that there is motion within this thunderstorms that actually bringing this drier air back around to the side of the storm. So not only are we seeing in this image kind of the rain-free base, no rain, but we're actually starting to see the clear spot or clearing skies. Spotter position, being with these types of thunderstorms, thinking that the storm motion is from southwest to the northeast, you can go by a right-hand rule. So when spotting a supercell, try to position yourself with the heavy rain to your right and updraft to the left. So that last video that we saw, the heavy rain was to the right, that murky color look to it, and the updraft was to our left, the rain-free base, dark, solid area. So a good position to be at would be right in this general location if you were to observe this supercell storm moving from the southwest to the northeast. Because in general, the heavy rain, hail is going to be off into the northeast portion of the storm, and then the tornado, if the were to produce a tornado, would be in this general location, all moving to the northeast. Supercell characteristics, circular structure, curved cloud bands, striations, spiraling low-level inflow bands. You will have that dark, flat, rain-free base again with the precipitation nearby, usually to the north and northeast, with the possible wall cloud. And this image right here, we talked about kind of the striations or the circular look to it. It actually will have a look that it's actually kind of moving in this striation. You can actually kind of infer that there's possible rotation with it, just the way it looks there. It won't span the entire sky, it'll just be in one location here. The striations are rain-free base in that general location, more murky clouds where the rain and hail is occurring, and this is where the wall cloud will be. You heard me mention that these storms will modify the environment. What we're hearing right now is actually the storm sucking in warm, moist air from the environment to help feed it. See the rain off to the left, the clearing that we're seeing noted before left of the screen. And you're seeing that very that is actually dust from the storm sucking in this warm, moist air. We can play that again here real quick. Murky color look to it. Where your downdraft of rain is at. Right here is where you get more towards the rain-free base. There's a wall cloud associated with this. No rain, clear, murky, dark, and rain hail. The right-hand rule. And once again, what we're hearing is a strong inflow. The thunderstorm is so strong that it's pulling this air into it to help feed it. So there is our wall cloud that we're seeing right there, lowering, confined location, tied to the main base of the thunderstorm here, the rain-free base. Warm rising air, you're seeing some good motion into that. On the right-hand side over here, is where the air is falling, the downdraft, cold air, the rain, the hail. Possible rotation would be in this location as well. Wall clouds differing, from our show clouds we talked about. Notice that, the show clouds of a line or a wide spanning the good horizon where, once again, these are more smaller confined locations tied to the main cloud base, the distinct lowering. You can see that in this top right image. You can see it in the top or this left image here. You can actually almost make some type of funnel cloud beginning to develop here with this lowering that we're seeing in this general location. You want to be looking for good vertical motion within this lowering. Is there any rotation within this lowering the wall cloud? All indications that maybe tornadic damage is not, or tornadic potential is not imminent, but is definitely possible. So you're looking at, is there motion within this? Is there vertical motion, or is there rotation within this wall cloud? And if we were to be closer to this wall cloud or now potential funnel cloud, we'd more than likely see this cloud base or this area within the wall cloud rotating or even possibly moving upward. Once again, wall cloud tied connected to the main cloud or the main cloud base. Wall clouds, although are ominous and do produce funnel clouds, tornadoes, less than 20% of wall clouds do produce tornadoes. Wall clouds likely to produce tornadoes will tend to be or exhibit rapid rotation, like I mentioned, and upward motion. Have strong inflow, so as we felt before, you could just feel the air flowing into this thunderstorm, and often have a clear spot, or in the far left side, just looks like a clearing, looks like a brighter area within the thunderstorm on the back side of that wall cloud. So main things, once again, rapid rotation and upward motion. We are looking at a thunderstorm with a distinct lowering of the cloud base. And as it moves kind of further into the central part of the screen, it's kind of tough to tell, but you are seeing rotation within this form. You're actually seeing motion from the foreground moving left to right, and as you get back in the background, they're moving from right to left. Something to be worried about at this point. And these are things that if you were to call into our office and tell us you are seeing a wall cloud, we would probably ask, is it rotating? Does it look like it's really developing? Or is it just really kind of really not doing much? These are things that to keep in mind when you're monitoring this potential. As you get towards the non-tornadic wall cloud, these are rain-free bays. The main cloud base is kind of up in this general location. We are seeing a receipt lowering here, wall cloud. But what distinguished itself differently from the previous image was that we're really not seeing that good rapid rotation. We're not seeing good upward motion there. Although there is a wall cloud associated with it, really not seeming to be an opposing threat at the time. Something to still call in though, that if you were to observe this, it's good information to pass along either to your local law enforcement or to the Weather Service office. So some more definitions here. We've got our funnel cloud. What defines that is it's a rotating cloud protruding from the base of the thunderstorm that is not in contact with the ground. So at this point, it is not in contact with the ground. A tornado is defined as a violently rotating column of air extending from the base of the thunderstorm that is in contact with the ground. So I stress in contact, but I'm also going to tell you though, the tornado is the wind and not the cloud. Not all tornadoes will have the condensation funnel visible all the way to the surface. And so although you may be looking at what you think is a funnel cloud, try to look at the ground as well. Are you seeing dust being flown about, being twirled around? If you are seeing that, but you aren't seeing that condensation cloud reaching the ground, you're still seeing the tornado on the ground. It's just at that point, that condensation funnel or even the resultant dust debris is not giving you the full visual effect of the ground all the way to the ground. Look for clues at the ground, dust being thrown about, debris, things of that. A gustnado is ground-based, usually short-lived dust swirl. It's not connected to the cloud base, usually along the leading edge of gust fronts. But we stress that a gustnado is not a tornado. Still something to keep in mind and to be aware of, as they do produce some minor damage. But in terms of pure definition from a tornado, it's really not a tornado. But once again, it's ground-based, usually short-lived, and not connected to the cloud base. There's the same funnel developing in this lower than cloud. That is our funnel cloud now developing. And at this point, it is now at the ground. Although from time to time you can see it not clearly visible with the condensation funnel, but kind of difficult to see at this point. But it did look like there was briefly some debris moving around the area. But I would say moving on at this point, sometimes it may be a little bit difficult to tell if the tornado is on the ground or not. That's why the vantage point is definitely good. As it moves out of the trees in this general rotation, you can tell if it is or not. At this point, we're still kind of seeing that funnel look really weakening, but it doesn't really look to appear tied to the ground at this point. Once again, no dirt, dust, or any debris being thrown about the area. So shell cloud, wall cloud, because that's the main thing here that's really going to provide hassle to people when they're trying to figure out what is what. The wall cloud, once again, more associated with supercell, is a local lowering of the cloud base, usually located back of the storm under the updraft, as we talked about. Favorite location for tornado development, and rotation, spinning, is sometimes visible. The shelf cloud, associated with squall lines, along leading edge of a storm, marks edge of the cool outflow downdraft, stretches far across the sky, strong winds possible as it moves overhead, and the rolling motion sometimes also visible. So, are we seeing a shelf cloud or a wall cloud? Oops, sorry. Top right, question A here. Are we seeing a shelf cloud or a wall cloud?
Shelf.
Why are we seeing a shelf cloud?
It's extending along the horizon.
There you go, shelf. All right, looking now then at B, it gets a little difficult here, but we'll do our best here. What at B, what do you think you might be seeing here in this bottom left image?
It looks to be localized.
Yeah.
Wall cloud, correct, yeah, the localized features to it. There's some indications, maybe it could be type of shelf cloud, but what we're seeing is that distinct local lowering from this main cloud base right in this general location. So shelf cloud or wall cloud, let's let it scan through here.
Shelf cloud.
Scanning the sky as we start to get underneath it. See the turbulent motion went to almost rolling as it moves across the area. So yes, you guys correct the shelf.
Wall cloud.
Everybody note the rotation within this, a little difficult to see.
See it.
But we're seeing the rotation within this location as well as the entire kind of base of the storm is actually rotating itself, so. Yeah, we'll walk through. Okay, so we'll continue moving on here. So, there's distinct challenges we're trying to define wall cloud, shelf cloud, but then there's other clouds, of course, that have to make our job more difficult as well. And that's kind of what we call scary-looking clouds, or it's SCUD, that's stratocumulus under deck. And so we'll kind of look at some images here and actually what it exactly is, and they really kind of try to help you guys to further distinguish what you are observing. SCUD clouds, stratocumulus, or we'll call it stratocu under deck. So it's the cloud underneath the main deck of the cloud base. They form as a result of high humidity air near the storm that is then actually being, that is also rising and forming those clouds. Can extend very low to the ground, but it is not an indication of severe weather. They are often fragmented and or not connected to the base of the parent cloud. There's no rotation, although sometimes rising into a parent cloud or near the updraft. So once again, fragmented, not connected to the base of the cloud, and can be very, very low. So this is actually a video of SCUD. What likely happened is there was maybe a thunderstorm that pushed through, dropped a bunch of rain. And now we have another thunderstorm moving across the area. This would be the updraft, so it's pulling in some air, but it's already rain that is piping into the air. So it's quickly creating these fragmented clouds as it actually gets suggested more towards the cloud. Once again, it's a little fragmented, really no definitive features to it, and not tied to the base of the cloud, although it does kind of look like here, but once again, that is just SCUD. We'll continue on with tornado impersonator. So there's other aspects of the atmosphere environment that can also make our job even more difficult. But looking for visual clues before reporting a tornado, is the feature rotating? That's the main thing there. Is it part of the storm, or is it part of the storm that you expect the tornado to actually form, now knowing some of the basic information I provide you? And is it in contact with the ground? Is that condensation funnel there? If it's not there, are you seeing debris at the surface? So is the feature rotating? Is it in a part of the storm you expect it to be? And is it in contact with the ground? This is actually a really good common tornado impersonator. What we're actually just seeing is a rain shaft. Remember we talked about that murky colored look to it? We're just seeing rain fall down to the surface and then spread in locations. But at first glance, it almost looks like there's some type of, column there that maybe would lead someone to believe it's a tornado. We're actually just seeing a rain shaft there. Smoke, sometimes it's just rising in the air, maybe it gets kind of ingested into an updraft, but something to keep an eye on. Is it rotating? Is it really tied to the thunderstorm? And is it location where you would expect a tornado to be? Also, blowing dust can be a common tornado impersonator. Down here at the bottom, you see dust being swirled around. Heavy rain is falling from the clouds.
Get out of here, man. No, hang on. I'll do it. Come on. Car, quick sides.
That's actually dust. At first glance, looks like there might be something connected to the cloud, but it's really not. It's really not rotating. What we are seeing is, sometimes you can maybe call it being a microburst, or wet microburst, is the rain bringing this really rain-cooled air down to the surface, hits the surface and spreads out in all locations. And even that heavy rain can provide, pretty strong winds. And that's actually what it was doing in this video there, was just providing pretty strong winds and blowing dust about that general location. Now this looks really tricky, Going back over this presentation in the spring, I had to look at this several times.
It's not rotating. It looks like smoke coming out from a fire.
Far away, yeah, I would have trouble distinguishing what I'm seeing. But luckily, the video did zoom in, and I can, could see it pretty good on the screen, but it's just not really doing much. It's just sitting there. There's no upward motion to it. It's not rotating. It's really not doing anything. It's not actually in contact to the ground. There wasn't any dust, any debris at the ground. So very difficult to say just the lowering of the cloud base, but really no tornado with it. So, if I were to see that, I would probably call that in, but I don't know what I'm looking at, but just want to pass that along to you. And I'll say later, any information is good information, to tell you the truth. And assuming that we always know everything is not always a good assumption, because everything's always worth a second look. So when you're calling in a report, who, things of that nature. So what do I report? Well, who you are, what you are reporting, when that event, and when the event occurred, not when you're calling, but when the event occurred, and where you are located, where you're observing this event. So what do I report?
Good afternoon, National Weather Service.
Hi, I'm a train spotter. I'd like to give a report.
Go ahead with your report, please.
All right, I'm experiencing some hail. It's about the size of a quarter. It started at about 3:40 p.m. and now it's 3:45 and it's still hailing, still quarters.
And what's your location?
I'm a mile north of Mendota, roughly at 22nd Street and East 2nd Road.
All right, thank you for the report.
All right, thank you.
Bye.
Bye.
Short and sweet is basically the main thing there. Who were they? They were a trained spotter. Described what was occurring, and they described when it was occurring, and not necessarily when the report was called. So the time of the event. Location is extremely important. There'll be instances where, say that we get a report from this location of 1-inch hail, but there's actually nothing over this location. Location is key. Maybe the report was relayed or things of that, and so the actual exact location got misconstrued. But nonetheless, making sure you get the location down as best as possible is a good thing to do to provide the good information to us. And however you do that, what's best for you, that actually provides a good location, I would say, is the best. GPS coordinates are acceptable, but I mean, estimating direction and distance to the storm feature is nice. Co-locating that with your nearest town, major intersections, things of that nature. Uncertainty is okay. Like I said, with that tornado impersonator, that we just saw there, you're going to have uncertainty. I'm going to have uncertainty even if I'm out in the field. If you're not sure what you're seeing, watch it for a while, and describe it the best you can. Uncertainty is better than overstating your certainty and ending up being wrong. So conveying that uncertainty is just as much good information as actually providing us what you might be seeing. Report is still very useful. We can correlate this information with other spot reports or actually what we are seeing on radar. And once again, even experienced storm chasers that we saw in the videos before, they don't always agree or always know exactly what they're looking at. So uncertainty is definitely okay. We want to hear from you. Like I've stated a couple times, do not assume that if a warning is issued, the NWS knows for certain that severe weather has occurred. Never assume your report is not important. And then also, do not exaggerate your report. All of this information goes through the warning process, so it can not only help out your location, but locations further down the road. So what do I report? With hail, we're looking for the largest hailstone observed. If it's measured to the nearest 1/4 inch, give it exact measurement. If it's estimated, do the best you can to relate it to a size of a coin or a ball. We've got baseballs, tennis, golf ball size hail, hail the size of quarters, nickels, things of that nature. What we don't like to see is that we're receiving marble-sized hail. Because as you can see in this image, there are many, many sizes of marbles. And we don't know exactly what kind of marble or what size of marble they were observing at the time. So we kind of advise to stay away from marbles, but do your best to provide that information to us. Or just doing your best is good. What to report with the winds, over 50 miles per hour and/or wind damage is good. For reporting damage, report as many specifics as possible and the location. If reporting measured wind gust, please specifically state that it was measured. And if reporting estimated wind gust, please stress that it was estimated. And then also, I'd like to stress that estimating wind strength is difficult. I can't do it, all the time, and I don't expect everyone to do that as well. But doing your best is the best thing. As is wind strength is often overestimated. But here's a quick, this little guide here that can kind of help you. And I believe it's in the booklet as well. Generally, when you see 40 to 50 mile per hour winds, you start to see trees sway. Some twigs will break off of trees, as well as lightweight loose items, objects being blown away. It's not until you get more towards the 60 to 80 mile an hour wind that you're going to start to see those large limbs break off, trees, shallow-rooted trees being pushed or uprooted, and shingles off the roofs. And then when you get really more towards the stronger winds, 80 to 100 mile an hour, structural damage to homes, partial roof loss, many trees uprooted, barns destroyed. Those are all things that you can help kind of piece together that maybe this might be what the winds were estimated at the time. And giving ranges like this is definitely not bad as well. So. Phonocalls and tornadoes, always report where you are, then approximately how far and in what direction it is from you. Is the rotation visible? How far does the funnel extend downward? Is there any damage or debris noted with the tornado? And with the wall clouds, generally it will report if it's rotating rapidly, lowering toward the ground, and there's actually rapid upward motion visible. So kind of what we talked about, that rapid rotation is key. Flooding and measured, or annual measured heavy rainfall, fast flowing water over roadways, estimate the depth of the water if possible, the deep impassable standing water blocking roads, once again estimate the depth of water if possible. Measured rainfall, if you're able to actually measure the rainfall, 2 inches or greater than 2 inches in less than 1 hour in a rural area, or greater than 1 inch in less than 1 hour in an urban area, are good information for us to have. Are the streams or creeks out of their banks? Are floodwaters threatening homes or businesses? And many home weather stations will report rainfall rate, although those are instantaneous rates that's actually occurring at that time. So some instruments will say that they're seeing 6.5 inches per hour, but it's actually only at tenths at that time. If you were to look at it for an entire hour, it would be nowhere near that. So giving us that rate that you're observing on your instruments is really not beneficial, but what more is the actual accumulated range, or at least the measured amount of that rainfall, and within what time frame as well. How do you report this to us? I've got the phone number listed here, but it's on your sheets of paper as well. That is our spotter number. If you don't have it already, there it is, and once again, it will be on your sheet. This is for severe weather reporting only, and do not give this number out. If you're part of an amateur radio, there's the website for that information as well, although I believe that's on your sheet too. Through social media, I know we've got Twitter on there, but on Facebook and Twitter, if you do follow us on either one of those, you can give us that information via those platforms. We've got Spotter Network listed on there. We do monitor that, so if you are an individual that is on the Spotter Network, we'll see you on there as well. I want to point out that eSpotter is no longer used. I don't know if individuals have been to a talk before or have been part of eSpotter, but we are actually discontinuing that at this point. So I'll have the website at the end, and I believe, I don't know if it got sent out. If not, we'll leave it up for a while so we can get it. But we're actually creating a storm spotter database. This would include your name, location, phone number, email, and when it is okay to call you. What's big about the spotter database, the spotters must attend the training every 2 years to remain in this database. And I'll show you the website again here momentarily, but if your report is urgent, like if you are seeing a tornado, significant wind or flash flooding, we want to hear it firsthand, so make sure to send or at least call us rather than any electronic delivery. So with the spotter database that we're creating, it's basically to help us really kind of assess what's going on. So in this graphic here, we've got the supercell moving across east central Illinois, northwest Indiana, and there our warning forecaster is saying, man, I wish I had a spotter, that would call and let us know what is happening. We always don't know what's going on, most times. But now with this new spotter database, we could have a list of individuals and know where these individuals are, and if it's okay with that individual, we could then call and try to reach out and be like, hey, you noticed there was a storm that moved across your area. Did you happen to observe, any type of wind damage or anything with that? And that's kind of what this is showing is now. Before, there was really nothing we had to call, but if we had a spotter there in Watsika, we could actually call them and be like, hey, you were in a pretty kind of location of the storm. What are you observing anything at this point? So the spotter database is really going to help us really kind of assess the environment and what's going on at the time. I don't know how many amateur radio operators we do have here, but we do monitor the amateur radio networks at our office. We've got one individual that is in charge of that program in our office, but we've got multiple individuals that come in and monitor during severe weather, and this goes out through various speeds. Here are the amateur radio operations that are across northern Illinois and northwest Indiana, from Reno, all the Winnebago in Illinois towards northwest Indiana, things of that. And so that is our Skywarn network there for amateur radio. Local storm reports, if you do provide us information, we will create what's called a local storm report, and it will actually specifically say, hail, Glendale Heights at 1 p.m., provided to us by a trained spotter. Basically, it's useful for us, but it's useful for everybody to know what's going on. The public, the EMs, the broadcast media, they're looking for this information. Hey, we just got reports out of Glendale Heights of hail. Those are going to be created with our local storm reports there. And the disposition of these local storm reports, we try to issue those as quick as possible, as to the storm. As soon as we get those, warnings will of course always have highest priority. Sometimes we get multiple reports of the same phenomenon in that same location, and sometimes that'll get summarized in one local storm report. All reports we receive and then send out at the time are preliminary. A final report is then sent to, or gets created within storm data that's published by the National Climatic Data Center, usually about 60 days after the end of the month. But I want to also say that if you don't see a report on our NWS webpage right away, don't be discouraged. We value all reports and we get them out as soon as possible. So we are actually using all and any information we receive at all times. So we kind of end this here with a little spotter quiz here, but this first question, the part of the storm with the rain-free base and building towers above is the blank area. Rain-free base, building towers, the upward motion, that's where we would see our updraft area. What is this? What are we seeing?
That's rain. Is that each,
Basically what, yeah, we're trying to kind of show you on the left side of the image.
downdraft?
Yeah, the downdraft, heavy rain, a little murky color to it. Kind of a lot going on here, so it's not too good. But yeah, a little murky appearance there with the downdraft and heavy rain. Good job. Yeah, we're seeing that real fragmented, and it kind of looked like it's tied to the base of the cloud, but if we were to get a closer look at it, it's really not. And you're seeing the multiple areas of scudding itself across this general location. The best position to view the wall cloud and possible tornado is A, from the north side of the storm looking south, from southwest of the storm looking northeast, using the left-hand rule, heavy precipitation and downdraft to the left and updraft to the right, or using the right-hand rule, heavy precipitation and downdraft to the right, updraft to the left.
Right hand roll.
Good job, D. You know, and as we can see with these videos and images, uncertainty is inevitable, but just doing your best to try to now sped up, what are we seeing?
You see them a little rotation.
So we were seeing a rotating wall cloud. It was kind of hard at first sight to kind of really tell exactly what it was doing, but looking in and speeding it up a little bit, you could see that there was a distinct lowering of the cloud base, and it actually was rotating foreground left to right and the background right to left. Good job. Once again, really looking turbulent underneath the shell cloud and then spanning the horizon. Blowing dust from the resulting downdraft. So we talked about when the rain comes down, it spreads out everywhere. Tornadoes usually occur in the downdraft and outflow at the leading edge of the storm when the sky turns green, in strong updraft, usually in the vicinity of the wall cloud, or when warm air and cold air collide. Strong updraft, yes, wall. Perfect. Good job.
It is rotating, right?
rotating wall tile with a funnel. So yeah, we were seeing rotation with it. On the left side, there was some type of funnel trying to lower down to the surface. So rotating wall tile with a funnel. When I call it a report, I should tweet the report first, give the current time, not when I observe the severe weather, forget where I'm at, say I'm a train spotter and give the when, where, and what I have. Good job. I should report tornado touching down behind your house, lightning and heavy rain, marble-sized hail, hail greater than 1 inch in diameter. Well, why wouldn't you report A? You should be in the basement, you should not be calling. Safety is first, people. We love information, but we want you guys to be safe, so good job. Okay, so just kind of into some more aspects of our website where you can provide or really get good information. And right now is actually a really good time to look at our river flood information. There on our main website, weather.gov/Chicago, in that bold blue column on the left, you'll see rivers and lakes. That is actually our Advanced Hydrological Prediction Service. This is where you'll see observed river stages from our river gauges across northern Illinois, northwest Indiana, as well as forecasts for these points. I say highly used right now because with the warming and the rain and then the resulting cold that we saw over this last week, we are seeing elevated river rises or river stages as rivers are rising due to ice and these elevated rivers. And so we are closely monitoring these river gauges for potential flooding in and around those locations, as well as quick ice jam that could provide world-class flooding. Yes?
Would you be looking for weather spotters to call stuff like that in?
We actually have a network called Ice Spotter Network. And if you want, I can pass along our service hydrologist name who runs that to you afterwards if you'd like. There's another network that's actually not part of the Weather Service, but we work with them, and they're a great source of information. It's called COCORAS. They're actually weather observers that measure rain, hail, and snow on a daily basis. You just have to sign up, and I think it's a small fee to sign up, or with that you get your own rain gauge, and you provide weather, at least basically rainfall every day, or if not every day, during more kind of a heavy rainfall events. But I'd say a good network to be a part of. The PING project, this is basically some research that's being done out of the National Severe Storms Laboratory in Norman, Oklahoma. They are part of the National Weather Service. This is basically an app that you can get through either Google Play or for your iPhone there. But what it allows you to do is actually report what you're observing. Are you reporting snow, rain, hail, sleet, and all that does is just send it back to a database in Norman, Oklahoma for research to kind of correlate it with radar signatures, things like that. So all the information that's being used is what you're observing at that location. Nothing personal, no personal information, things like that. But it just helps us for research purposes to help continue to help correlate what we're observing on radar and what people are observing at the ground. So ending with preparedness, education, or key, and with advanced warning, or the keys to saving lives. It's a good way to be prepared. We've got the website for ready.gov, but also too, we have a Storm Ready program that either schools or programs or communities are part of. That would be something with your local emergency management, but that basically what it is helps locations become more weather ready and through various means of having storm plans, things of that nature. But there's a website for that as well. Lightning safety, lightningsafety.noaa.gov. And then there at the bottom, there's our QR code. If your camera can get that far. If not, that's for our Twitter, Facebook, and YouTube feeds. Twitter, we're at NWS Chicago. On Facebook, we just search National Weather Service Chicago. And then our YouTube channel is National Weather Service, or NWS Chicago, excuse me. And that's basically it. Yeah, this is actually an image from Coal City this past November. And my boss always loved this statement, and it's a true statement. But it's only a matter of when, not if, a major tornado will strike our area. Definitely something to live by, as we saw this past November. Always good to be prepared and weather ready. But thank you for attending, and we value your reports. And there at the bottom is that website, If you would like to become a part of our spotter database, you just go there, provide your name, address, phone number, email address, if we can call you, things of that. All that information does not get shared anywhere. We are a government agency, stays within our office, goes nowhere. All it would be used for is to try to further assess what's going on. But if you do go to that website and sign up, we very much appreciate that. But yeah, I thank you for your time, and I can welcome any and all questions. Yeah.
In the city, is there any incentives how to see if there's a Chicago?
Oh, and the city itself?
Yeah, there are a lot of sirens go off lately.
But the actual, well, what's really neat about the city itself is we are now including in tornado warnings certain codes that then the Chicago Office of Emergency Management can then utilize to see which sirens to sound off and which one not to use in the city. Whereas in the past, if I had an issue of tornado warning in 5 seconds in the city, since the city was included, all tornado sirens would be sounded within the entire city. But now we include code that the city knows not to sound the sirens on the north side of the city as opposed to the south side. So, but in terms of being able to spot, it gets very difficult just because we've got so many obstructions. Just being prepared of what could happen within that day and what could possibly happen in the near term is the best way to say get prepared.
But not spot.
What?
But not really be a spotter.
Well, if you observe something at your location, we welcome that information. It just makes it very difficult to see.
I have a
Yeah.
question. How would you classify heat lightning?
Heat lightning? Yeah.
A lot of people will see it and they don't know what it is.
It's lightning. You know what I mean?
Right, but it doesn't have to zigzag.
All it needs is charge separation. Clouds, the droplets, the ice, are kind of, we call them they have a polar aspect to it, a positive and negative charge. All it needs to happen is those charges to separate and enough charge separation to occur, then you get a lightning strike, and that can occur even when you really don't have rain in some situations. So I think that's why you get that heat lightning per se, but lightning nonetheless. So.
Yeah, right.
Any other questions? All right, thank you for your time.